This video we would be discussing about moment of inertia. So inertia, we are already familiar with this word inertia. See, in the topic of forces, we have seen that if there is some vehicle moving with some velocity and has mass m, so we say that this body has an inertia. So this body will resist any change in the motion, and Newton's second law also says that the body will resist the change. So if it is moving with suppose 50, it will try to move with 50 meter per second until and unless we put some force of like some brakes or some other force to stop this, or to increase it also, like to make it to 80, we also need some force to change it. So inertia is the resistance by the body. Similarly, in circular motion, when there is some body moving in circular pattern, it has some inertia, and that inertia is known as moment of inertia. And this moment of inertia is also similar to the inertia that we have already discussed, that it will resist the motion, it will resist the changes in the motion, and the formula for that is mr square, where r is the radius and mass is the mass of the body. So this moment of inertia in discrete system, like if we discuss like this, if there is a single axis here and we have like r1 m1, r2 m2, r3 m3, and r4 and m4. So if we will add all the inertias together, so we will get the net inertia. It is a summation of mi ri square, where I is from 1 to 4. So we will add all the inertias together and we will get the net inertia of all of the system. So it is a scalar quantity, first of all. That's why we are like able to add it without any taking directions into consideration. And second, the unit, the SI unit will be kg meter square. So this will be the SI unit and it's a scalar quantity. So now for the continuous objects. Continuous objects means, like suppose there is some bar like this, and this is the axis of rotation like this. This is a pen and it is moving with like this from the center. And if it is moving like this, so it will have a different moment of inertia. So like this. So this, it's a bar like structure. So it could be like rectangular also, it could be like spherical also. So then there would be different objects like disc, sphere, or cylindrical bodies. So for this, the formula will be 1 by 12 ml square. Whereas for this, the formula will be 1 by 3 ml square. So length is L and mass is M. So like this, there will be different formulas for every object. You can see your data booklet for all those formulas. So I'm not writing all the formulas here. So the thing that you have to learn is, there is moment of inertia for circular motion. The formula is mr square. It is a discrete system. We can add up them and it is a scalar quantity. Units are this. The formulas would be different for all the bodies depending upon the axis. So the next part is, now we will compare the translational motion with the rotational motion. So we will write here translational motion to rotational motion. Now you see that the formula for force, we all know that is F equals to ma. So for from translational to rotational, this m will be converted to inertia. So formula will be, first of all, this force will become torque, and torque will be I alpha. So this A will be alpha here. After that, there is momentum. Momentum is mv. So here the momentum will become L, that is the angular momentum, and this m will become I, and v will become omega. So like this you have to relate all the formulas. Then there is another formula of that is impulse, and impulse is delta p. So change in the momentum. So this is momentum, this is change in momentum. So here the momentum, the impulse will be change in the L. Okay, because P has changed to L. Similarly, the formula for work we have already done, that is Fs. So here the formula for work will become, this F will be like torque and this S will be theta. So these will be the formulas for comparison. Now the major formula, very important formula, the last one is energy. That is kinetic energy. Half m v square. So this will become half, m will become I, and v will become omega. So this formula will be for the rotation. So now I am covering the next topic, that is the energy part. It is very important. See, if there is a hinge, there is a plank like this. Okay, like this. And there are some objects here. Suppose this will roll down. So what energies this will have? So this will have energies. First of all, it will have potential energy. So it will have mgh. You can write here potential energy. Then it will have kinetic energy, that is half mv square, and then it will have this energy, that is a rotational kinetic energy plus, that is the half I omega square. This is very important concept because there would be some questions that this object will be rolling down. So when the object will roll down, it will also have, the center of mass is going downwards. Okay, like the center of mass will go down. So this will create kinetic energy translational. But this circular motion will be also there. So this will also add a rotational kinetic energy. So you have to always take care of these all energy formulas. Now there is another concept, that is the last concept, that is angular momentum. We have already discussed a little bit. Okay, momentum. So in this topic, see, the P is equals to mv and L will become IR. So this formula we have already discussed right now, but now we will just consider this example to see it. Like suppose this body is rotating with radius r and velocity v. So the I will be I omega. So I, for what is will be the I here? I we already know, that is mr square, and omega is v by r. So r and r goes off. So L will be mr. So this formula is also very important. So similarly, the moment of inertia for every body is different. So L formula for all the bodies will be different. So like for a body which is a rigid body, so this body is moving like this from the end. So at that time that L will be equals to I omega, and I for this will be 1 by 3 ml square into omega. So like this we will be calculating the I, the L. So for different values of moment of inertia, there will be different values of L. Second and the last in this is conservation of momentum, angular momentum. So like if you remember, there is conservation of momentum where we say that P is equals to P, that P initial is P final. Similarly, L initial will be equals to L final. What it means is, we have discussed like there is some momentum, then there is a collision, then there is another momentum, and we say that momentum for this will be equal to this. If you remember the collision part that we have done. In these types of questions, there will be, like suppose the disk is there, a disk is rotating. After that, there is some another object sticked here, or another object, something changes. So the L of this initial, it will be equal to the L for the final, that is the angular momentum. So conservation of angular momentum is also one of the very important concept and topic in rotational motion. So with this, our rotational motion topic is completed. You can practice more and more questions from your book. So, and if you have some doubts, you can just put it into the comment section so we can work on your problems. Thank you for being here.